What does the graph of an exponential function look like? So we're going to take the function f of x equals 3 to the x power and find out, what is this thing going to look like? So we got some inputs here, -4, -2, -1, 0, 1, 2, and 3. So we're going to plug these in for x and find out what 3 to that power would be. So let's do the easiest ones first. So if I plug in 1, f of 1 would be 3 to the first power, and that would be 3. So for an input of 1, I have an output of 3. F of 2, 3 to the second power, 3 times 3 would be 9. So for an input of 2, I have an output of 9. And with 3, f of 3 would be 3 to the third power, or 27. And notice that my graph here only goes up to 10, so I'm a little bit too high. 0, 3 to the 0th power would just be 1. Anything to the 0th power is 1. So that point's going to be right there. 3 to the negative first. Remember how you deal with negative exponents. That's going to be the same thing as 1 over 3 to the positive first, or 1/3. So when my input is -1, my output is about there at positive 1/3. 3 to the negative second would be 1 over 3 squared. So I'll just make that. And 1 over 3 squared would be 1/9. So a little bit closer here to my x-axis. And -4, 3 to the -4th power is the same thing as 1 over 3 to the 4th power, which is 1 over 81. So at this point, I'm getting very, very small. Okay, so let's see if I can draw my curve here. I'm going to try to carefully go through these points the best that I can. And all right, so there is a rough sketch of my graph. Now let's answer the questions over here on the right. So what is my domain? When you think about domain, you're thinking about inputs. Are there any limitations to what I can plug into this function for x? And the answer is no. I can plug in positive numbers, I can plug in negative numbers, I can plug in 0. I know I didn't do any fractions or decimals, but I could do 3 to the 2.7th power if I wanted to. So my domain is going to be all real numbers. I can plug in anything that I want. No matter where I go along this x-axis, there's always going to be an output. Granted, when I get over here, the output's going to be very, very large, but there's still an output. My range. When I'm looking at range, I'm talking about outputs or y values. And if you notice, all of these y values here have something in common, and that is that they're all positive. Notice there is nothing happening down here. I don't have any points below the x-axis, and if I kept going to the left here with my x values, I would just keep getting closer and closer to 0 without ever actually touching it. So I basically kind of hit a wall here, so I'm never going to drop below this x-axis. My range is going to be basically the set of all positive real numbers, or in interval notation, everything from 0 to infinity. Intercepts. I'm never crossing the x-axis, so there is no x-intercept, but there is a y-intercept right here at the point 0, 1. So I have that one y-intercept. Asymptotes. You might be tempted to say that there is a vertical asymptote here, but there is not. This thing increases very, very quickly, but it's not like it's going to hit a wall. There's going to be an output at 3. And we calculated that. It's 27. There's going to be an output for 4 and 5 and 6 and so on. So this thing, although increasing very rapidly, is never actually hitting a wall where it can't cross over. So there's no vertical asymptote, but there is a horizontal asymptote here at my x-axis, or at the value y equals 0. Is this increasing or decreasing? As I go from the left to right, notice that my outputs are getting larger. This is an increasing function, and because I can draw this without lifting up my pencil or my pen, yes, this is a continuous function. And this right here, when you see this shape, you want to associate that with the idea of exponential growth.